When you're graphing something, you want y to be your output, which is why we solve for y. We want to put something into the middle of the equation and know what we're going to get out. So every time we're getting ready to graph, we're solving an equation for y. If you remember, solving is the opposite of simplifying. It's getting one thing by itself. So we do PEMDAS backwards. We do the adding and subtracting first, and we do the division and multiplication second. The shorter way to remember that would be that we take away the terms farthest away. If I look on this side of the equation, because that's where the y is, and I find my y, the farthest away from it is this term 8x. So I keep my 8 with my x, but I subtract both of them. So I'm going to erase that underline to make sure it doesn't look like division. But I'm going to do minus 8x on this side. If I do minus 8x to the left, I have to do minus 8x to the right. On the left, it reduces, and I've got negative 4y equals, on the right, or on the left, it cancels. On the right, it's negative 4 minus 8x. Because I can't say that negative 4 take away negative 8. They're not like terms. So I just say I've got negative 4, and when I know what 8x is, that's when I'll take that away. Now my last step is I see I've got negative 4y, which really means negative 4 times y. So I'm dividing out the negative 4, dividing out the negative 4, dividing out the negative 4. We can remember it as terms farthest away, or we can look at our PEMDAS. We added or subtracted first, now we're multiplying and dividing. Negative 4 divided by negative 4 right here becomes 1y. We've got on this side, negative 4 divided by negative 4 is positive 1. And on this side, negative 8 divided by negative 4 is positive 2x. Because it's positive, I do need to stick that plus sign in the middle. And now it's as good as having y by itself. I can erase this 1 because we know y is just 1y. That's all you have to do to get y by itself. Take away the term farthest away, take away the coefficient, and make sure you've got y by itself. However, when we're going to put it in slope-intercept form, if you remember that form is y equals mx plus b. So we want x with its coefficient to be in the front. This is not about graphing, it's just about solving. So I am going to put it in that form, but we won't worry about solving it, or graphing it. Y equals positive 2x, and then my 1 goes at the back, positive 1. Y equals 2x plus 1. For my next example, I suggest you pause it and try it on your own first. Alright, we're going to look at our y value. The thing farthest away is this 3x term. So we're going to do minus 3x on both sides. I've got minus 3x here. I've got a positive 9y, so I can just bring down 9y. And here, again, they're not like terms, so I'm going to write 6 minus 3x. Some of you like to not have to flip it around, so from before you wrote this line here, you saw that you had a negative 3x and you had a 6. So instead of this, you put 9y equals negative 3x plus 6. These two are the same thing. In the last example, I switched it at the very end. This time I'm showing you the shortcut because some of you are already using it and I don't want you to think you're doing anything wrong. So either way, I've got negative 3x and I've got 6, no matter what order they're in. I'm going to divide by 9, divide by 9, divide by 9. 9 and 9 make 1, so I've got plain old y equals. Here's where some people tend to get confused. They want to make it a decimal. You don't need to make it a decimal. You can leave negative 3/9. However, negative 3/9 can be reduced, so off to the side I'm going to do that, and I get negative 1/3. So once I've reduced it, I've got negative 1/3 x. I'll put my negative up here so you can tell it's not part of the fraction bar. Negative 1/3 x. For my other fraction, 6/9, again I'm going to reduce it on the side. 6 divided by 9, it becomes 2/3. So I'm going to leave that as 2/3. And it's got a plus in the middle. Y equals negative 1/3 x plus 2/3. All right, another example. This one just looks a little different. All you need to do is simplify this side before you solve. You simplify that by distributing your -2. -2 times x is -2x. -2 times positive 3x is times positive 3y is -6y. And that still equals 18. Now it's exactly like the other two problems we did. We want to get rid of the -2x, so we do plus 2x on both sides. We want to cross this out. We get -6y equals, and I'm just going to write 2x plus 18 because, as you know, as long as you've got this guy and this guy, you can switch them when you're adding because the commutative property told us we could. My last step, divide out -6, divide out -6, divide out -6. These two become 1, so it's y, or 1y, equals -2/6 reduces to -1/3 x. Positive 18 over -6 reduces to -3. There's my answer. Y equals -1/3 x minus 3. These are the three ways we've seen problems a lot lately. However, they could be a little different. For example, this one has the y on this side. Well, all that means we have to do is flip it around to put y in front if we want. 10y equals 5x plus 10. Okay? And to get y by itself, I'm going to divide out the 10, divide out the 10, divide out the 10. Cancels. Y equals 5 over 10. I'm not going to put a decimal because remember, this is going to become slope. So 1/2, that way later I can use rise over run. 1/2 x plus 10 over 10 reduces to 1. Y equals 1/2 x plus 1. All right, this one here, you've got a y over here and a y over here. So before I even start solving, I want to make sure I can combine my like terms. And in order to combine my like terms, you can move either one of them. But I would prefer to move the 2y because I won't have a negative number. So -2y, -2y, 3y plus 8 equals, these cancel, -3x plus 5. Now, I've got only one y, so I need to get rid of the other terms on that side of the equation. In this case, that's that 8. I need to subtract 8. On this side, I also need to subtract 8, and I don't know if I'm going to do it here or here, but when we're subtracting, we don't distribute, we only do it once. These two are not like terms, these two are, so it's much easier for me to put my -8 with the term it goes with, bring down -3x minus 3, because positive 5 and -8 makes -3. All right? On the other side, these cancel, and all I had left was 3y. So 3y equals -3x minus 3. My last step is to get rid of this 3 that they're multiplying, so I divide it. Divide by 3, divide by 3, and I've got y equals -1, or -x, same thing, minus 1. All right? Do another example. We've got x plus 5y minus 10 equals 2x. So here's my y, and there's this term and this term all on that side of the equal sign. It really doesn't matter which one you get rid of first. I'm just going to get rid of x because it's out front. Minus x, minus x. These two cancel. I've got 5y minus 10 equals 2x minus x. That's really 2x minus 1x. So it's just 2 minus 1 is 1. There's 1x left. All right, now I've got to get rid of my 10. So I'm going to add it because that's the opposite. and I've got 5y, then my 10s cancel, equals x plus 10. The last step is to divide by 5 and get y alone. Divide by 5, divide by 5. All right, now when I divided by 5 with my y, it cancels. Here I've got x over 5 plus 10 over 5 is 2. This is technically solved for y, but we're working on getting it in slope-intercept form. And this is not mx, this is x over 5. The other way to think of x over 5 is 1x over 5, or 1/5 times x. So I'm just going to rewrite it a little differently. Y equals 1/5 x plus 2. That's nothing new from the other problems we did. I could have stuck my 1 in up here to start with and had 1/5 as well. Either way, this is my answer written in slope-intercept form. And that is all 6 problems I have, but I've got plenty more if you still need practice solving for y.